Hello, my name is Joaquin Lopez, and my project is equipping a high school chemistry lab for an early career in education. And I've been working on this project with my advisor, Don Bregel. So, a quick summary and goals for the project. Main goal is to remove the stigma and intimidation that surrounds chemistry. And I'll be doing this by integrating students into the chemistry program by providing a curriculum that highlights the practicality and presence of chemistry in everyday life. Um, and these goals will be executed by purchasing pH probes and a calorimeter, and developing laboratory exercises that introduce students to acid-base chemistry and spectrophotometry. And with luck, the funding for this equipment will be provided by the American Chemical Society or a similar grant. So why is this work important? Um, like I said, there is stigma that surrounds chemistry, and yes, chemistry is difficult, but so is any other major. And I think all it takes is a willingness to learn and curiosity and hard work. um, and with that you can be successful in any major. And I think difficult concepts in chemistry can be introduced early in life. Things like acid-base chemistry especially can be visualized um, when you're young to kind of soften the impact when you introduce to them later on. And I hope that this projects like these lead to more chemists in the world. And on a broader scale, I hope projects like this lead to more young people in STEM. So the first experiment would be determining the acid concentration of a given soft drink. Um, the goals for this experiment is to become familiar with LagerPro software, which is a software that we use to visualize and analyze data that's collected, and also to learn the basics of acid-base chemistry. Also, I hope the students learn to perform titrations to determine acid concentration. In order to perform this experiment, we'll be using a pH electrode. And so what is a pH electrode? Basically, it's a glass tube that's filled with a buffer solution of known acid concentration. And once it is put into a solution, the difference in acid concentration creates a readable potential of reference electrode versus the substance tested. So basically, the potential is used to give a pH value. In order to determine the acid of a soda can, first you would just measure the pH of a common beverage, because it's interesting to see you know the pH of your soda can versus a glass of water, or something similar. And then you could titrate the beverage with a base to find the equivalence point. Um, and this is what a titration curve looks like. Um, Basically, what you do is you have an acidic solution, which is down here. Low means acid. And then you keep adding base and becomes more and more basic until it reaches an equivalence point. And the equivalence point is when the amount of base equals the amount of acid. And you keep going further until you get a basic solution. So you could determine the concentration of acid by using the equivalence point and the moles of base used to titrate. So since the equivalence point is where the moles of acid is equal to the moles of base, if you know the moles of base that you added, then therefore you also know the moles of acid. And the students may see multiple equivalence point and multiple curves. It might go like this and then go back up um, a few times. So it's important that the students may ask themselves, um, what can multiple equivalence points mean? What does that hint towards? The second experiment is determining the quantity of iron in a vitamin tablet with a standard curve. And the general goals for this experiment is to use spectrophotometry to determine concentration. And I hope the students will become comfortable with Beer's law and get some good practice with dilution calculations. So how does the colorimeter work? Basically, what happens is light is passed through a solution via a series of lenses. Um, you can kind of see it shown here in this graph. Um, Once the light is passed through, it can be read with a detector, and the absorbance can then be calculated from the amount of light that passes through. And that is basically, in essence, what Beer's law means. It says that there is a correlation between the amount of light that passes through a medium um, and the properties of said medium. So how we will do this experiment is first we would prepare a vitamin sample solution. And we do that by dissolving and purifying a sample of an iron vitamin tablet and then complexing the iron in the tablet with SCN to colorize it. And we do this because the iron would usually be colorless, um, and color is required to be read through the colorimeter. Then we would prepare standard solutions of iron by diluting a concentrated stock solution and creating a series of stock solutions of known concentration. And that can be shown in this image here, where you have the most concentrated solution, which goes down to be diluted to the least concentrated solution. And once you measure the absorbances of each of these vials, um, you should get a standard curve that's linear with known concentrations. And after you've done that, you can determine the iron content in the vitamin sample by measuring the absorbance of your sample and then comparing it to the linear fit that you achieved from part 2 in the experiment. And you could do that by using the linear fit equation, y equals mx plus b, that you get from part 2. The third experiment will hopefully encapsulate ideas from both the first experiment and the second experiment by measuring the quality of drinking water with pH probes and colorimeters. So first, we would use the pH probe to estimate the toxicity of water. I would ask students, what if the water is acidic, what might that mean in terms of the toxicity of it? Or if the water is basic, what might that mean? Um, and using the same methods we used in experiment 2, we can screen for certain toxins using the colorimeter. So instead of iron, we can screen for other toxins that might be present. And we could then use data to determine, the students can use data to determine if the water sample is safe to drink or not. And basically, I would ask them, would you drink this water and why or why not? And I hope that the students will be able to make a good educated answer on why or why not the water would be drinkable. So the student impacts and outcomes, 105 students will be impacted. This is based off of my high school back in Galt, California, where we had around 30 students in 3 different classrooms. And the chemistry department as a whole will use these instruments in each classroom for every level of chemistry taught, because these instruments aren't exclusive to intro chemistry or advanced chemistry. They're things that I've used my entire time at Pacific, and they're easy to use, and they really carry a lot of weight. And I hope that this project bridges the gap between lecture and lab and helps students visualize the concepts learned in class and bring the concepts back home. Hopefully, asking themselves, I wonder how acidic this soda is compared to this vinegar or this water. Asking questions like that, I think, are really important. And like I said earlier, I really hope that projects like this make chemistry less intimidating. How I know that my project has succeeded or failed, I'll know when the project has met its goals by the lab reports submitted by the students in my class, along with the exams given to them. So I plan on, taking data from past exams, exam scores before the curriculum was implemented, and then comparing them to data after the curriculum was implemented. Along with that, a survey will be given to the students for a self-assessment on their comfortability using the equipment before and after class. Because like I said, the equipment they use, a pH electrode and the colorimeter, are very important, and I've used them in almost every chemistry class I've taken that had a lab attached to it. And that's it. Thank you all for listening, and I'm excited for your questions.